What sets SpaceX apart from the rest of the space industry? The power of reusability. Every product they create, whether in part or whole, is designed to be reused, and SpaceX wields a sharp weapon that no other American company currently has, a space taxi that's fully operational, Dragon. SpaceX has been sending humans to the ISS on Dragon so smoothly for 4 years. Now it's time to answer the question. What are the limits of Dragon's reusability? Just how powerful is it, and how does it outclass its competition? Let's find out in today's episode. Current limitation. Remember Dragon Endeavour. The spacecraft is currently docked alongside Starliner on the International Space Station, ISS, for the Crew 8 mission, its 5th flight. This makes Dragon Endeavour the most flown spacecraft in SpaceX's fleet, a testament to the reliability and reusability of Dragon. Do you know how many flights a Dragon is officially certified for? 5. So, on paper, Endeavour has reached its limit, and retirement should be its next step. But no, SpaceX believes this spacecraft has plenty of life left in it and is determined to prove it. During the February 28, 2024, press briefing on the Crew 8 mission, Steve Stick, NASA's Commercial Crew Program Manager, revealed some exciting details. SpaceX is conducting an in-depth examination of every component of the Dragon to determine the maximum number of safe flights the spacecraft can achieve. Stick shared, "We are right now embarking on what we call our extended Dragon certification. We're working on that this year and probably next year to see how long they will fly Dragon." The point is, what's the final target NASA and SpaceX have in mind? It's 15. 5 is impressive, but 15 would be revolutionary. What are NASA and SpaceX doing? So, how are they planning to extend Dragon's certification for more flights? NASA and SpaceX are undertaking a comprehensive and complex evaluation process. This includes rigorous qualification tests designed to assess the durability of each individual component of the spacecraft. It's crucial to remember that no part can last forever. Like any complex machine, spacecraft components wear down over time, especially in the harsh environment of space. After every mission, SpaceX conducts a thorough inspection and upgrades specific parts. This process is ongoing throughout the spacecraft's life cycle. Take the Pica X heat shield, for example. It's replaced after each mission. That's quite a major overhaul. Valves are another component that requires special attention. You see, Dragon lands in seawater, and saltwater is particularly harsh on metal valves. Essentially, a spacecraft is like a tank with rocket engines and tons of intricate valves. Valve leaks and corrosion are frequent issues for any spacecraft, demanding constant vigilance. Here's the point. The propellant used by the Draco engines, hydrazine and NTO, nitrogen tetroxide, don't mix well with moisture. Specifically, when NTO comes into contact with water or humidity, it produces red fuming nitric acid. This is a highly corrosive acid capable of causing severe damage to the spacecraft's metal components. For this reason, SpaceX must perform extremely meticulous checks on the propulsion system after every mission. This process may involve cleaning the entire system, inspecting every tiny detail, and replacing specific parts as needed. In fact, Boeing, SpaceX's main competitor in this field, has also faced similar issues with valve corrosion due to moisture in their Starliner spacecraft. This setback forced Boeing to delay the Orbital Flight Test 2 mission. Reusable spacecraft, in some ways, are like cars. Just as you frequently replace tires and brake pads on your car while the frame remains intact, spacecraft also have components that require regular replacement and core structures designed for long-term durability. John Posey, Dragon's chief engineer for NASA's Commercial Crew Program, emphasized that while many smaller components on the Crew Dragon are regularly swapped out, the spacecraft's primary structures remain unchanged. Specifically, parts like the capsule, welds, bulkheads, and pressure vessel, the essential skeleton of the spacecraft, remain original after multiple flights. Some individual components have been approved for up to 50 flights. This is an incredibly promising sign for SpaceX, showcasing the enormous potential for extending Dragon's operational lifespan. This number could exceed the 15-flight target that SpaceX is currently aiming for, suggesting that with ongoing development and refinement, Dragon could achieve even greater longevity in the future. But it's not just about conducting qualification tests on grounded spacecraft. Steve Stick, NASA's Commercial Crew Program Manager, revealed an ambitious plan involving SpaceX's Dragon Endeavour. Once Endeavour completes the Crew 8 mission and returns to Earth, expected within the next 2 weeks, NASA and SpaceX will conduct a comprehensive inspection. Engineers and scientists will meticulously analyze every component of the spacecraft, with particular focus on parts that have endured years of exposure to the harsh conditions of space. The goal is to assess the capabilities of Endeavour, deemed the fleet leader of SpaceX, in undertaking even more missions in the future. You know, Endeavour is the most seasoned spacecraft in SpaceX's fleet, having spent the most time in space. If it can prove its ability to fly beyond its expected limits, it could pave the way for the entire Dragon fleet, 3 active ships and 1 in the pipeline, to achieve a similar operational lifespan. This would be a monumental step in optimizing the cost and efficiency of space missions. Now, this evaluation process isn't a quick or simple task. It's expected to stretch throughout this year and possibly into the next, all in a bid to precisely determine how many safe flights each Dragon can realistically accomplish. In this era, the concept of reusable spacecraft has become almost second nature to everyone. It's the strategic goal that all leading space organizations are chasing, of course. They all want to dramatically cut costs and ramp up the frequency of space missions, unlocking new opportunities for exploration and the commercialization of space. So, we're witnessing an exciting race among reusable spacecraft: Boeing's Starliner, NASA's Orion, Sierra Space's Dream Chaser, and of course, SpaceX's Dragon. Each of these spacecraft has its unique characteristics and goals. Starliner, designed to be reused up to 10 times, aims to rival Dragon in ferrying astronauts to the ISS. The Dream Chaser, a mini space shuttle by Sierra Space, is targeting up to 15 reuses. And then there's Orion from NASA. Although designed for reuse, NASA engineers haven't yet pinned down the exact number of safe reuses for Orion, likely because they don't have enough data to determine this capability. These numbers sound impressive and full of promise. However, there's one common thread among these spacecraft: reliability. Dragon has been successfully ferrying humans to the ISS since 2020, smoothly and consistently. Meanwhile, none of the others have yet earned human-rated certification. We all know that Boeing's Starliner has struggled to complete a full mission cycle, from launch, docking with the ISS, to returning to Earth without a hitch. Technical issues have repeatedly delayed its development. Orion, despite completing the Artemis 1 mission around the Moon, isn't yet ready for the crewed Artemis 2 mission. NASA engineers are still addressing numerous issues, particularly with the heat shield, a critical component for ensuring crew safety during re-entry into Earth's atmosphere. As for Dream Chaser, though its design is unique and promising, it's progressing at a slower pace. Sierra Space is currently focused on the cargo version of Dream Chaser, and it might be a few more years before the crewed version sees the light of day. And here's a critical factor that often flies under the radar: the cost of disposable parts with each flight. This aspect is pivotal, directly impacting the overall expense of each mission, and ultimately, the ticket price for every astronaut. Let's take a closer look at this. Both Boeing's Starliner and NASA's Orion share a notable feature. They use a separate service module which houses thrusters and a variety of other high-tech components. This service module plays a crucial role in orbital adjustments, providing power and maintaining a livable environment for the crew throughout the mission. However, once the mission is complete, the entire module is jettisoned, either left behind in space or incinerated upon re-entry into Earth's atmosphere. The issue here is that these components, especially the thrusters and control systems, are incredibly expensive. They're built with high precision using advanced materials and cutting-edge technology. Discarding such valuable parts after each flight significantly drives up the cost of every mission. Similarly, Dream Chaser features the Shooting Star, a detachable cargo module. While this design allows Dream Chaser to carry more cargo, it also means that a significant portion of the spacecraft won't be reused after each mission. In contrast, SpaceX's Dragon takes a more streamlined approach that's highly cost-effective. The expendable part of Dragon is the trunk, a relatively simple structure housing the solar panels and thermal radiators. This simplicity not only reduces the overall cost of each mission, but also highlights SpaceX's strategic focus on efficiency without sacrificing performance. It seems both NASA and SpaceX are keen on extending the operational lifespan of the Dragon spacecraft. SpaceX is currently under contract with NASA to conduct flights to the International Space Station, ISS, until 2030, the projected retirement date for the ISS. However, this timeline could shift. Theoretically, SpaceX might complete up to 5 more flights for NASA under the current agreement. But here's the interesting part. If the ISS's lifespan is extended, a very real possibility, NASA could require even more Dragon flights. NASA's vision goes beyond the ISS. The agency is eyeing a handover of research and technology projects in low Earth orbit, LEO, to the private sector. Currently, NASA has received dozens of proposals from private companies to build commercial space stations. Among the prominent names are Axiom Space and Blue Origin, both heavyweights in the commercial space industry. It's expected that at least 2 new space stations will be constructed to maintain a continuous U.S. presence in LEO after the ISS retires. With more destinations in orbit, the demand for a reliable transportation vehicle like Dragon will skyrocket. Other spacecraft are still a while away from being ready to fly, so NASA doesn't have many alternatives. This situation is leading to a surge in demand for SpaceX. With 5 NASA missions already on the books and several private flights on the horizon, Dragon is currently flying 3 to 5 missions a year. Soon, there may be 1 to 2 Axiom missions and, in the future, 2 launches for Jared Isaacman's missions. The demand is high, which means the pressure is on to prove Dragon's extended reusability. SpaceX is already building the 5th spacecraft, which is tentatively planned to fly the Crew 10 mission in 2025 and will be ready by next fall. Alright, that's it for today. If you enjoyed this video, please give it a thumbs up and subscribe to our channel for more in-depth looks at the latest advancements in space technology. Thanks for watching, and I'll see you next time.